Okay. Today I will, can you see my PowerPoint?
Yes, sir.
Yeah, okay. Today I will explain chapter 9. Chapter 9. Chapter 1 through 8 is a foundation to do all following subject. Okay. Population, for example, population mu standards we do not know. So we will take some samples. Sample size is a small n. And then we will calculate sample mean and sample standard deviation. And using these three, sample mean, sample standard deviation, and sample size, we will try to estimate what is mu. Where is mu? What is the value? Or there are two things. We will, this is estimation. We will estimate the mu, what is mu, or what is the range, with a lower limit and upper limit. Population mean may exist between some lower and upper limit. Between that there's interval. We want to find out interval at confidence level. Confidence level, it depends on it. Probably 95%, the probability that actual population mean may exist within the range is 95%. Then 95% is called confidence level. Okay, so it means maybe population mean is lower than lower limit or bigger than upper limit. That percentage is 5%. 5% could be error. Okay, at the 95% will be correct. The population means may exist between that interval. Okay, there's two things. The first one is when we want to estimate what is mu directly, that is called a point estimate. If you want to find out the interval is a lower limit and upper limit, it is called confidence interval at some, for example, for 95% confidence level. Okay, so we have two things. We will compute a point estimate, just one number. Second is we want to estimate which interval will include the population mean and so on. First thing is point estimate. In point estimate is a single value. It is a single value. Population value is parameter, or say population mu is an example of parameter. This is a parameter. Characteristics of population is called parameter. But when you pick up the sample size of small n, we calculate x, y, and s, and so on. All the thing is called statistic, sample statistic. Okay, so we will use statistic. Okay, wait a minute, and then here. Example is suppose the Bureau of Tourism for Barbados, they want to estimate a mean amount spent by tourists visiting the country. Barbados is some country name, and Bureau of Tourism, they want to find out what is mean value. Let's say x is how much money spent by tourists. Okay, so the average mu is mu x, or just simply the mu bracket x, either way, okay? Mu is, or simply just mu is population parameter mu sample mean, we do not know. So they randomly selected 500 tourists. Now sample size is 500. And they measure x1, the first person, second person, up to 500. Okay, and then they calculate x bar. X bar is the mean amount of, so we calculate this one and sample standard deviation, and using x bar, we'll try to mu. Using x bar is a sample statistic. Point estimate is I will use this number directly. If sample mean is, for example, sample mean is 200, for example, then mu could be similar, like close to 200. If sample mean is 300, we assume population mean is 300 and so on. That's only using just one number to estimate a single value, to estimate population value. It is a point estimate, but it is not very accurate. It may include lots of errors may include there, because one extreme person, he spent $2,000, or he spent only $10, you know, very big or very small number is selected, and then the people and value will determine the total population. So based on this, it could be reliable when n is large enough. If n is very large, then x bar will be close to mu. Okay, when sample size is very large, sample mean can be used as a single estimate of population mean. This is true. But if n is small, x bar and mu cannot be close. So we cannot use the point estimate. Point estimate is reliable only if the sample size is big enough. Okay. Next, we will try to move confidence interval for a population mean. When now population sample size is not big enough, a confidence interval, a range of values within which the population parameter is here. The most important population parameter is mu. Population mean is expected to occur. So a range of values constructed from sample data so that population parameter mu is likely to occur. Mu could be within this range, okay, bigger than this or lower than this. We want to estimate this interval at certain percentage of confidence level. Most widely frequently used is 95% confidence level. So when if, for example, 95 interval is like that, and how about 90% confidence interval is narrow? How about the 99% is could be range is more wider and more wider. Okay, the factor that determines the width of confidence interval is sample size n, and standard deviation s, sample standard deviation, and what percentage is it? Maybe 90 or 95% or 99%. Okay, by these three factors will determine the confidence interval. Let's look at the example is to determine the confidence limit when the population standard is known. The first case, so underline here, when population deviation is known, sigma is known. Population is here, mu is unknown, but standard deviation is known. Based on our historical data, we realized that then we can use the Z distribution. When mu is known, there are two cases. One is when sigma is known. Second, when sigma is unknown. Okay? The first case, when sigma is known, we will use normal distribution table and like this. X bar mu located between, for example, here, X bar plus Z sigma square root n, X bar minus Z sigma divided by square root n. The Z value plus 1 at 95% confidence level, Z will be 1.96. And you see the normal distribution table, you can find out this one. Okay. How about look at the table? 99%. So, for example, here, for 95% is half of 95%. 95% divided by 2 is 0.475. 475. The Z value, here Z value equal to 1.96. You know this one. How about 99%? 99% is half of 99. 0.99 divided by 2 is 0.495. 0.495. Then what is the value here? Look at the table. 0.495, 257. 2.57 and 2.5 between that. So it's better than 2.575. Okay, when Z is like that, it will confidence in the Z value here. Okay, the Z value will depends on confidence level. Okay, 90%. 90, and then this will be 0.45. 0.45 is 1.6. 1.645. 1.65 and 1.64 between them. Yeah. 1.64, 1.65. So in the middle, 1.645 will be used. So you can use all these numbers. You don't need to memorize. You can look at the normal distribution table and you need to read it. Or 1.96 is better to remember. It's widely used, so it's better to remember. So when you look at the table formula is the interval will depend on Z value. Z value will be determined by confidence level. And also, and what happened? Look at here. Look at the formula. Okay. So Z value will be determined by confidence level. And the denominator is a sample size. Sigma is standard deviation. So previous slide, you already, the factor that determine the width of interval is depends on N, S, and Z value. Z value will be determined by confidence level 90, 95, and 99. Okay, so you need to memorize. You don't need to memorize. You already know this one. Okay, chapter 7 chapter 7, 8 we have studied normal distribution table. Normal distribution of sample mean we have already this. So it should be divided by square root n. It's a very important thing. I will delete everything, okay? And the next slide. Let's try to find out the value of Z value. The last page of our textbook, or you can get these numbers from internet. How do we get Z value? Z value, and it will be determined by confidence level. When confidence level 95% divided by 2, so I will use purple color. This is 95%. Then what will happen? The half of them is 0.95 divided by 2 is 0.49. Here 0.4750, 0.4750. So the remaining 0.025, remaining 0.25. When you add these two is 5%. The purple area, this is 95%. Okay, then 0.4750, you need to look at the table. The last page, our textbook says, on the top, it is some percentage is given, and so we need to look at the Z value. When Z is 1.9, second decimal is 6, you can find a 0.4750. So 1.96, Z is 1.96 will give is 0.475. Then total left and right, both are symmetric, so multiply by 2 is 95%. Okay, you can use this one or normal distribution table like this. Our textbook is, look at here, 1.96. Second decimal going down, as you can find out. Okay, this area is 0.475. Let's have an example of level of confidence. Our textbook is chapter 9, what page? Page 282. American Management Association is studying an income of a store manager in retail industry. A random sample, 49. N is 49. Reveals a sample mean, X bar, this is X bar. Standard deviation population, now in this case, sigma is not S, this is sigma, 2050, is known. When the standard deviation population is given, what is point population mean? Because we do not know population mean, right? Basically, we do not know. So we can use it, best estimate, we can use X bar as point estimate. So we will use point estimate directly, like this. What is population mean? The answer is we do not know exactly, but we can estimate the population mean could be equal to sample mean. But this is only possible when n is large enough. But in this specific case, n is 49 is not big enough. It's not big enough. It means actual population mean is mu could be different with this one. Maybe bigger, maybe different. Okay, but I do not have any other options. Only one sample. Because I have no other choice. No other choice. Even though the sample size is not big enough, I will use sample mean as point estimate for population mean. Okay, that's second question. What is reasonable range of value? So range means confidence interval. We'll try to find out confidence interval at 95%. So look at the equation. Equation is x bar. The previous one is x bar plus minus z value. But z value is 1.96. Sigma, we know that sigma is 2050 divided by square root 49. Okay, so there is some value is missing here, so I will erase. The then one is x bar. X bar is 45,000. X bar is 420 plus minus 1.96. 2050 divided by square root 49. Okay, we need to calculate this one. That one is our textbook, page 283 says 45,120 plus minus 574. Then we will calculate the interval is like this. This plus minus 574 is called margin of error. The margin of error. You need to understand the terminology. Okay. So interval will be calculated sample mean plus minus margin of error. Sample mean x bar plus minus margin of error. Margin of error will be calculated like this. Z sigma divided by square root n. And it will be margin of error. Second case is when population standard deviation is unknown. We do not know. Okay, when it is unknown, when sigma is known, we can use normal distribution because population is known there. But if we do not know that, we need to calculate x bar, sample mean, and sample standard deviation. And then you may say x bar plus my z value, sigma square root n, you can, but in this case, in most cases, you cannot use z value. Z distribution is like this, like bell shape, like this. But T distribution is when sample size is small, it is more flat, like this. That's T distribution. Previous one is just normal distribution. When sample size is just not big enough and population standard deviation mu is unknown, then we need to use student. Now this is developed by the professors when a professor examine and students part-time, how much they earn during part-time job and so on. That it is symmetric, but is not allowed in the center, around the center. Is more spread. Okay, some student has a lot of money, but some student very low money and so on. So we will use t-value. For example, is Dean of Business College want to estimate the mean number of hours. Full-time students, how many hours they are working at the paying job each week. So mu, where is the mu? But n is 30. And asked how many hours they work last week, he can calculate sample mean. Using this one, x1, x2, and here's x30. We'll calculate x bar and sample standard deviation. But it is unlikely he would know the population standard deviation. Sigma, we do not know. So we will use S. So while we are using S, also at the same time, we cannot use the value. So the two cases, mu is known or not. Is known, we will use just distribution. When sigma is unknown, population standard deviation unknown, we need to use t distribution must be used. So the green color is z distribution, but gray color is t distribution, is like a little bit mound shape. It's symmetric. Both are symmetric, but it's spread. Standard deviation is much bigger, is flatter, and more spread out than compared to standard normal distribution. Okay, in that case, we need to use t-value differently, finding a value of t. How we can find out? So we need to know degrees, any sample size. And then n-1 is called degree of freedom. So in our textbook, we will have this one. Our textbook t distribution is located in appendix B, page 748, page 748, 749. Okay, it has degree of freedom and confidence level. So confidence level, 95 confidence level, means actual mu is located within there, but outside it is a half alpha. Alpha over 2 is another alpha over 2. So alpha is outside is called here significance. Significance level. 1 minus alpha is confidence level. Alpha is significance level. You need to understand the terminology. So 95% means 5% significance for two tail. For one tail is only both sides here is 0.025. Another 0.25. A two tail problem is 5%. One tail is one side is only 0.025. Okay, we need to know the confidence level 95% here, and n is 10, sample size 10, n-1, degree of freedom is 9, and then we need to look at this way, and this is t-value 2.262. Look at the table. Example 289. you skip some pages, okay? 289. At the bottom is a tire manufacturer wishes to investigate a thread life of its tire. Sample of 10. Sample size N is 10. And tires driven 50,000 miles reveal the sample mean X bar 0.32, remaining a standard deviation of S 0.09. Sigma unknown, we do not know. 95%, so alpha is 0.05. 1 minus alpha is 0.95. Would it be reasonable for the manufacturer to conclude that 50,000 miles, the population mean of the thread remaining is 0.03? So, is it possible mu is 0.3? Is that correct? Yes or no? So the answer is we need to find out the mu is upper and lower limit at the 95%. At 95 confidence level, lower limit, upper limit, we will calculate, and then we will check whether 0.3 is within that interval. Okay, so example is X bar. X bar plus minus T. T I have calculated already. T it was 2.262. This is T. Multiply S 0.09 divided by square root N. Then we will calculate it and minus it like that. This lower limit is upper limit. Then 0.03 is within here. Right? So 0.3 is here. So probably the question is, the mu is 0.3 inches. Yes, it could be. Okay, mu could be 0.3 at 95% confidence level. It may be not. The error, if the probability that 0.3 is not the population mean is 5%. The probability that mu is 0.3 is 95% sure. Okay, so 95 confidence level is very important. So plus minus this one is called the margin of error. We already mentioned it, okay? Because the value 0.3 is in the interval, so it is possible that the mu is 0.3. This could be correct answer. The probability that this answer is correct is 95%. Okay, that's confidence level. Then again, our textbook at the end of this, I copied this one. Okay, and look at degree of freedom is n minus 1. 10, so 10 minus 1 is 9. Look at 95% in two-tail. When you're going down, you need to find out this is t value. And I will open in Excel file first. Page 282. American Management Association is studying is income. The X is income of store manager. Mu is unknown. we want to find out interval, confidence interval, okay? Sample size n, 49. So x1, x2, we just interview. We find out all 49 managers' monthly salary, annual salary, how much they earn, and we calculate X bar. This is X bar. Page 282, the standard deviation of population, this is wrong. It is population. Population standard deviation, sigma is known, 2050. Then how can we calculate this one? Okay, I will demonstrate how to do it. Store managers. This is error. It is not sample, it is population. The population standard deviation. Yeah. Now, data, when you enter this number is given, I just entered this number is myself, okay? If you have data, so all data, 49 data is in vertical column, and then you need to calculate, okay? And let's assume we have 49, we have calculated this one, and we get population standard deviation from our historical data, and then go to data, and then in data analysis, look at data analysis. I cannot find out any confidence level is not there. There is no information is given. So I will use megastart. When you megastart, descriptive and blah, blah, in the last one, yeah, look at again. Megastart, when you see confidence interval, I'll click this one, and you will have such a information. The mean, your confidence interval for mean, mu, confidence interval for population parameter p, the sample size, how to calculate sample size. Okay, here you need to choose what you want. Okay, you need to choose this one. This is default, and then mean is here. You need to click it. Standard deviation, population standard deviation is given like that. Sample size 49 and 95% when you click it, 90, 95, 99. So our question is 95. And Z value and T value. Then you need to look at the population. Population standard deviation is known, so we will use Z distribution. Here, preview, when you click it, you can see the view. But if you want detail, click OK. Then it will create, you will copy and paste here. I have calculated already for you. Okay. So our textbook says page 283. In the middle of 45,420 plus minus 574. 45, 420 minus 544 is this one. 45,420 plus 544 is this one. Okay. So we already have this one in PowerPoint, you know. I erase everything. Okay. Here and here. Here. Example was here. This example is I have solved using Excel. Okay. Okay. So there is some mistake. Some number is missing here. Okay. Just ignore this one. 420 plus or minus 1.96 multiply standard deviation 2050 divided by square root 49. Okay, then the answers are this is plus minus. Here some value is missing. Divided square root n. Okay, so you can find out this one, and I already explained, but same thing, I solved using Excel directly. Okay, if such a question is given, you need to know the principle, why we calculate in that way. Okay, the formula, you need to understand formula, but practically you can use the Excel program to calculate lower and upper control limit. If you do not understand just using the Excel, if you have mistake, your answer is completely wrong. If you understand the principle, and if you are mistake when you're using Excel, you can recognize something wrong, and you may correct your mistake, and then you can finally you will get correct answer. Page 84 is we have some more like for many years of automobile leasing business, Town Bank knows that mean distance driven on an automobile with a 4-year lease is 50,000 and standard deviation 5,000. So when we have a 4 years lease car, population mean is around this. This is our assumption. I really want to know average of population is really 50,000, but standard deviation is known. We know this one. Sigma is known. Sample size. So in the fifth row is the Town Bank decide to choose a sample size of 30 observation. 30 observation. And then see X1, X2 has up to X30. Everything. And then calculate. This is X bar. X bar. Okay, here. And 95 confidence level. Then what is lower limit and upper limit? They want to check it. Okay, this one is the same way I have used data, megastart, confidence level. When you have a previous one, you need to click clear button and disappear, blank, and then mean is, sample mean is here. Standard deviation here. Sample size here. Okay, 95. Standard deviation of population is known, so we will use that value and click OK. And you have these numbers. This number is attached here. Only this is I have solved for the first sample. First sample of size of 30. If you can do it next time, can you do this one? I will try to solve the second case. Clear. And average, I do not enter here. I will just enter directly 50.77. 50.77. I just entered directly. Standard deviation is 5,000. Sample size, same as 30. And the value. Preview. I will do it again because it's not 51. This is 50,770. It's not 50.7. 50,770. Okay. Standard deviation. See, this number, 48,981. Second case. Okay, upper 52559. We already have this one. We will continue. Let's try to have this case. Sample number 6. Sample 6. Average was 47,730. Okay, standard deviation is 30. Preview. 49,940 lower. Upper is 49,519. We will continue after all 60 samples. Okay. Number 60 is cut off. Textbook is 60. When I copy and paste some number, one number is missing. Then what we will do? The yellow case. The question is, our population mean is 50,000. 50,000 must be within the interval. The first sample, yes, 50,000 within here. Okay, good. Second sample, okay. Third sample of size of 30. Okay. But here, no. 50 is not within the range. And then okay. All here, yellow part. All yellow part is 5 samples with yellow background do not have 50,000 in that interval. But we tested 60 times. 55 out of 60. What is percentage? So you say 55 divided by 60. And 91.67% is within the range. 8.34% is outside. Okay, so that is given page 284, 285. So what it means, even though we estimated, you see, is 95 interval. I said 95% yes, 5% is no. But we have tested it 91.67%. Here, 8.33%. So because we test only 60 times, if you test more and more, it will be close like that. 95% will give correct interval. 5% will result in wrong interval. It will be estimated. Okay? 289. 289 at the bottom is tire manufacturer. The sample of N. So when you use T distribution, sample size usually small. N is small. And sigma unknown. Okay. Sample size 10. Sample mean X bar. sigma is unknown, so we will use sample standard deviation S. 1 minus alpha, confidence level is 95%. 10 minus 1 is 9. 95% is 2.262. So t value, we need to look at the t table, or when you use Megastat, it will give you that one, okay? With page 290, we have calculated this one. It's 0.32 plus minus 2.262. S is 0.09 divided by square root 10. Okay, it has 0.32 plus minus 0.064. We calculate this one is minus means 0.256 through 0.384. This is range interval for 95% confidence level. Okay, but same thing is will be calculated by Excel. Okay, how to do it? I will demonstrate. Data and the Megastat and the confidence interval. Okay, now is confidence interval for mean. Yes, mean we have calculated mean is here. Standard deviation, we have sample standard deviation, and sample size n equal this 10. So it's not z value. You must choose t because sigma is unknown. Sigma is unknown. We need to use t value. Okay, when you click OK, you will have this result. When you click preview, this number will appear directly. When you click OK, it created some pages like this. You can copy and paste. Page 291. 291. The manager of Inlet Square Mall near FT Mile, Florida, wants to estimate the mean amount spent per shopping visit by customers. So they want to know how much money is spent by per customer. They have chosen 20 customers, a sample of 20 customers. So this is 20. This is 20 customers. You can check it, this one. 1, 2, 3, and then when you enter 3 numbers, break down, it will create total 20. Or you can count, okay? For this one, it is what is the sample size is equal to COUNT. See, because you enter the 20 numbers, you do not want to know. Right? This total is count. So here 20 is I entered manually, okay? Sample mean is average. So you need to say average of, select all this range. Sample standard deviation equal to STDEV. Dot P is a population standard deviation. Dot S is a sample standard deviation. If you do not use, default is a sample standard deviation. And enter. You have this one. Degree of freedom is equal to this minus 1. Okay? When you have this one, look at the data, Megastat, interval, and then we calculate. Wait a minute. All right, here. I will clear first. We will the confidence interval for mean, yes. Here mean we have calculated. Okay, standard deviation, sample standard deviation. So we cannot use Z value. We must use T value. Sample size, and sample size is not this. Sample size is 20. Okay, and to choose, click OK. Then you have this result. I have pasted here. Okay. So T value 2.093. Okay, so is so we need to look at the table. Is our textbook does not have page 2. The page appendix. The page number is not there. Okay, student T distribution. From the behind is second page from the behind, or you can use table B5. Table B5 on page 748. So degree of freedom, you need to look at 19. And confidence level 95%, and look at here. 19 is 2.093. You can get from the table, T distribution table. Okay, and then you can calculate the formula like the X bar plus minus T. Here T is this one. Multiply S square root N. S is here. Root N is root 20. So X bar is 98,696 plus or minus 2.093. S is 18,02422 square root 20. When you calculate this one, you will have this one. And this term is margin of error. Margin of error, this is 8.436. Is calculated already. Okay. The question is the population mean mu is 100 is correct? So we assume based on our 20 samples, mu may be bigger than 90.26, less than 10.7.132. The 100 within here, yes. So the first question is yes. We can say the population mean located within the around 100. The probability that my correction population mean is 100. The probability is accuracy is 95%. If the population mean is 115 beyond upper minute, the answer is no. It could be, but its possibility is very, very low, lower than 5%. Okay. You can do a similar way. Let's try one more thing. 296. Look at here. So we have finished that one. One more thing is learning objective 3. We are continuing to estimate confidence interval for P. So our textbook use different notation. The population and sample. We will calculate P, small p, but here pi. What is the pi is between some interval. We need to find out the interval. Concept is we will calculate sample proportion P. Sample P is out of sample size N. X is the number of success. success. So for example, is Southern Tech Career Service reported that 80% of its graduates enter job market in the position related to their field of study, relating to their major. 80% is so when they check it, the P is 0.8. Second example, a recent study of married men between 35 to 50 found that 63% felt that both partners should earn a living. So how many married husband feels his partner must work and to make money is 0.63. But this is only sample result. Recent study is a sample because of the sampling result. This is another sample. Population pi, we do not know. Using these numbers, we will try to estimate what is the population properties and so on. Same thing. So we will assume it to require binomial. Each individual person to identify pi, that we will assume binomial with the value is n pi, n minus n times 1 minus p. So should be greater than equal to 5. So how can, and pi is 0.9, 1 minus pi will be 0.1. When it's increased, it will be small and so on. To settle both of them, n is large. When n is large enough, you can use normal distribution assumption from the central limit theorem. So in that case, pi should be p, the sample property plus minus z value. The n is large enough, square root pq, p times 1 minus p divided by n. And this is, we have studied already in chapter 8. Look at the example 296. The union representing Bottle Blowers America, BBA, is considering proposal to merge with the Team Master Union. There are two unions. One is Bottle Blowers America, BBA, and Teamster Union. Two unions, they want to merge. And it is suggested, proposed by the by two, unions leaders. But to do it, at least 3/4, more than 75% of the PBA members must approve any merger. So to do it, more than 75% people should agree. But population size, capital N, is very large. We cannot do that. So random sample size is 200. You see, sample is still very large. Sample size is 2,000. And 2,000 people random sample reveals that 1,600. So when you divide each number, it's 80%. 80% people approved the merging. When we find out using these numbers, can you find out what is pi? Population proportion. Okay. What is estimated population proportion? Can you conclude that the necessary proportion PBA members favor the merger, and why? The thing is, first is, if you are using point estimate, you can say that yes, 0.8. So it's bigger than 0.75. You can go ahead. But it could be some errors. It's better to calculate confidence interval, 95 confidence interval. N is 2,000, so we will set value 1.96. 0.8 plus my 1.96 square root P is 0.8 times Q 1 minus 0.8. 0.8 times 0.2 divided by n, 2000. Okay? Multiply 1.96 plus or minus and p bar 0.8. You need to calculate this one. When you calculate this one, okay, this is much easier. And then when you divide it, this minus this, is when you add up this one, so interval is like between them. So we conclude that the merger 0.75, even lower limit is higher than 75%. So the merger will likely pass because interval estimate include the value greater than 75%. Okay, the lower limit is bigger than 75%, so we can use it. Same thing. Page 296. Say, sample size 2000, number of success 1600. So I divide this number is 0.8. So confidence interval, I want to know this one. Data megastart, confidence interval, I will clear. And then mean is, so here, confidence interval mean, confidence interval P. We need to choose the second one. Confidence interval for proportion P. P is here. Sample size is 95%. Okay. And then you have this one. I have copy and paste here. Okay, I will do it again. And you have confidence interval, click it and preview, and the lower limit, upper limit is obtained. Okay, 0.782 to 0.818. Okay, upper and lower confidence limit is calculated. So you need to choose the second one, confidence interval P. I think it's better to take a break now, okay? After 15 minutes, so break, and then I will continue, okay? Let's take a break here.